Day to you, and we have a cat who's checking to make sure, yes. It's December 1st here in Chico, California, and to kick off this Christmas month, we'll be dealing with basic geometry, but not the way you and I were taught it in school. We were taught linear geometry. And granted, there never has been any other kind of geometry. I only deal with what can be proved, but in this case, what we're attempting to do is extend our knowledge of geometry. It appears that I have made a major discovery. If I were an accreditable scientist, that might be something worth listening to, and then you would learn nothing, because there is nobody in science today who can make any further progress. There just simply is none being made. And the reason for that was a progressive discovery that I made through the use of a spherical geometry, a geometry of curvature, which science has never had. By applying that, I found out how physics can go forward again. Now, I am not a physicist, neither a subatomic particle physicist nor a cosmologist. So I don't use hyper-extended linear geometry to make nonsensical theoretizations. That's what you get on YouTube, and that is in fact what you get in higher echelon science exclusively now, and for about 50 years, or 70, or 100, depending on a lot of different factors, including one's own subjective or personal point of view. Now, what we're going to be doing today is going back to basics, but not in a boring way. Certainly not. This is a hyperbola that you can bring up onto your screen as well, and I'll show you how to do that. It's not particularly well centered here, but it will be in the future. I just wanted you to see that we will be looking at the hyperbola, a most interesting curve. We'll also be using GeoGebra proper, which is the desktop version. Now, the desktop version of GeoGebra, which you can download for any operating system, is the most powerful geometry system in the world that is available to people like you and me, but I doubt that there's anything better because it can literally do anything. So GeoGebra is an indispensable tool for certain explorations or investigations, research. You may or may not want to download GeoGebra Desktop, and if you don't want to, you are favored by the GeoGebra people themselves say that you should use the online version. The online version. Now, there are several advantages to doing so. And I won't go into that now because we want this to be a brief introduction to our basic course in geometry. This is simply a circle with a radius, but you'll see there are some interesting inscriptions around it. I wish to begin here because you are looking at, right, singly in this one frame, you're looking at the three geometric objects that exist. For any geometry, there are no other objects except what you see here, except there are actually four, and you could say that there are more than four. Just to refresh you to what we were taught in school, rather laboriously, but I think we all got the same information. That Euclid defined a point, and you'll see that. It's rather large. Actually, a point does not exist, and that's the genius of the Euclidean system of geometry, is that its axiomatic basis is not a line. It's not a line. The first sentence in Elements, Euclid's famous 2,500-year-old book but it's really 3,000-year-old information. The exclusive foundation of science is depicted with that point, which is an amazing thing to say. And you and I are going to concentrate extraordinarily on the point. Because it's an error, the point does not have any existence. It's the perfect definition of a number. A point is considered to be the representation of any number, and I'll be showing you why that's so, although you may already know. Don't worry about what you already know, because most of what you already know needs a thorough overhaul, but this will not be tedious. In fact, this is going to open up the windows of geometry, mathematics, physics, and the universe and science to you. This is what science is for. So, that is one of the four basic objects, is the point, and it is absolutely unique. It has nothing in common with any other geometric object because it's non-existent. It's a pure abstraction. That is a most profound statement, a most profound assertion to be able to make. The other object, which is the only object known to science, science cannot know about the point because the point has no existence. It has a definite meaning in mathematics, but it has no meaning in geometry, and I'll be proving that to you. This is to commence a series on basic geometry, which will run through Christmas. In this series, in each one of the lectures that I present, which are meant to be brief, perhaps 20 minutes long each, but no more than that, you will be learning something of utterly, transcendentally profound significance in every single presentation. I will be showing you the fundaments of actual geometry. What science uses is a derivative geometry. That needs to be proved, but I can prove it. I already have. I'm simply going to share the proof with you. Science is about proof. It's not about theory. It's only about proof. So I'm making the statement, the assertion, that the point is a unique pseudo-geometrical object that forms the basis of a fake number system that has certain limited use for humans, but none for reality. None for the physical universe. No reason to use linear geometry because it doesn't explain anything. What it does is it gives us the ability to measure distance, and that's all science can do. And science has never been able to measure anything else accurately, precisely, or even realistically. This is all within the context of universal understanding. The currently touted term for that is the unified field theory. When that is defined correctly, then there is no such thing as the grand unified theory. That's simply a derivative. And there's no such thing as the theory of everything. That is a derivative. You can look up those two terms, the toe and the gut, and you will be able to verify what I say about those two terms. They're worthless. They have no substance. Because in science what you want is simplification. And if you have three terms for the same thing, three theories, that's an extremely bad sign. I'm going to correct that situation for you, as I have done for myself under the tutelage of the universe, directly taught to me by the universe, no intermediaries. I begin where Euclid began, and I take the turn that Euclid could not take. It was impossible for Euclid, just as it was inevitably for Einstein, Dirac, and Feynman. Nobody has been able to transcend the playpen, the sandbox of linear geometry. So it begins with a point, and you'll see that that point has two functions in this very simple drawing. Now, the main item from the point of view of science is that straight line, and that is the only straight line that makes any sense in geometry. It's called a radius. You never need the diameter. That was a mistake. I'll be showing you why the diameter is a false line, but the radius is a true line. The way Euclid defined the line enabled a perfect definition of distance, and that's why Euclid is immortal, but that's the only reason. Euclid is said to have first systematized an axiomatic approach to science. That is probably accurate, but nobody can really say for sure. What he did, what Euclid actually did when he formulated his Elements, which is quite a long book, he began with a point in order to make a line the way that he knew it had to be made. So the line is made of points. If those points are all separate, then it is called a quantized metric. A quantized metric. What that means is no number can exist in two places on the line. It can only exist in one point. And by itself, the point has no dimension, so it's not a geometrical object. The point is not a geometrical object. What it is an axiomatic abstraction. It has to have properties, though, but the properties of a point are extrinsic. There is no intrinsic property to a point. It has no position. It also has no momentum. And lacking both of those properties or qualities, you can call it either one in this case, then the point is non-existent. So by itself, it's a non-existent object. That's a contradiction. An object is defined as having some kind of existence. Well, the catch is, the good catch, is that it has a kind of existence using what is called an extrinsic reference frame. And this is so profound and mental and spooky and weird and philosophical that it must be defined. You cannot leave the point with the definition that Euclid gave it, which is what? Zero. He said that. He did not use the word zero. He did not use the word null. He did not use the word non-existent. He did not use the word abstract. He said, plainly and simply, as his axiomatic statement, an axiom means that you can't prove it. And that's where you must begin. It is zero-dimensional. It has zero dimensions. That means it's not even in the universe. It's only in the mind. So why is the point so critical for science? Why has all of science used nothing except points? It's because of that radius that since the point at the center is 0d, that makes it the center of a circle. Does it? You could say so. If you take a compass with a sharp end, which would be the F finger, that's a note on the musical scale, the F finger, and this is the pencil, or vice versa, and you thrust the needle point, that is a 0, it's a non-existent point at the end of that needle, and you stick it into the paper. We use paper, but it is into a flat surface, and then you rotate it all the way around. That gives you a circle, and you can see with your own eyes that there is a center to that circle. That is a different definition of a point. That is the main single item that I'm going to teach you today, that there are two definitions of the point. One is Euclidean, and the other one, by definition, is non-Euclidean. Don't forget, this is a musical finger. It has nothing to do with, It's really, really tragic. We have such miserable communication that this would be considered a rude finger to use. Well, in Spain, this is rude, okay? Probably in some part of the world, this is rude. It probably means castration, okay? We don't need that in science. We don't need that distraction. So this is the non-Euclidean definition of the point. You have both of them in this diagram, and there's so much more, but we're coming up on 20 minutes, so I'm going to hasten my pace. That line that's called the radius has a non-existent endpoint at the center and another non-existent endpoint at the surface. Those 2 points have completely different characteristics. The way I stated it is the way science uses those points, but neither of those points is correctly defined. Because let me ask you this, are those endpoints part of the line? Are those endpoints, either one, part of the line? Yes or no? You can't answer that. You cannot answer that. If you say yes, you are wrong. If you say no, you don't know why you said no. That's why I'm here. So that line going from the center to the edge is the only definition of a line. So now we have an ambiguous definition of the point. Do we have a rational definition of the line? Not at all. Not yet. The line has no meaning in the universe. It means nothing. Now you and I both know that it does have a meaning now that we know that it represents distance. But why does it represent distance? I hope you realize that Albert Einstein disproved that a straight line is not distance. It's at least 2 things. And that number 2, you are going to come to respect and honor in the way that you used to honor 0. But there's a number in between 0 and 2, at least on the line there is, and that's the number 1. And that is a transdimensional number because it represents unity. The number 2 represents duality, but the number 0 represents nullity, and that single fact has destroyed science. Destroyed it. No matter what you think of technology. This is Anagalactic, bringing you the secrets of the universe, and now the fundaments of geometry taught correctly for the first time in human history. Stay tuned. We're going to be having a lot more to come. This will be running through Christmas. Keep looking up.